This is the video demonstration for the Cooperative Adaptive Cruise Control prototype for Team 2. In our prototype, the user selects one of the scenarios at the top of the screen. Once a scenario is selected, the user can modify the scenario in the box below. The Modify the Scenario section is not something that a driver would be able to view. The purpose of the Modify the Scenario section is to set variables that would be outside of the driver's control. The first scenario demonstrates the adaptive cruise control feature of the software. In this scenario, a platoon of 2 vehicles is traveling at a constant speed, and the trailing vehicle is following the lead vehicle at an unsafe distance. The driver of the trailing vehicle then enables the Cooperative Adaptive Cruise Control software. Once the software is enabled, it will calculate a safe driving distance for the 2 vehicles based off of their initial speeds. It then calculates the time it would take the trailing vehicle to reach this distance from their current distance and the final speed of the trailing vehicle once it reaches this distance. The 4 inputs for Scenario 1 are the speed of both vehicles, the deceleration rate of the trailing vehicle, the initial distance between vehicles, and the slope of the road. The deceleration rate is a set value that is based off the vehicle that the user is driving. When the road slope is positive, the vehicle is driving at an upwards angle. And when the road slope is negative, the vehicles are driving at a downwards angle. The values calculated by the Cooperative Adaptive Cruise Control are then displayed here. When the trailing vehicle reaches its safe distance, it will then begin accelerating at the same rate that it decelerated at until it matches the speed of the leading vehicle. When the user edits the Modify the Scenario box after the software has been enabled, it turns off to avoid displaying the wrong data. Error messages have been implemented to detect when the software would fail or not be needed. In this scenario, the user is already at a safe following distance, so no deceleration would be required. Scenario 2 shows off the lane keeping feature of the software. In this scenario, the user modifies the distance from the center of the lane in the Modify the Scenario box. Once the software is enabled, the wheel angle is calculated so that the vehicle can properly return to the center of the lane. A negative angle indicates that the wheels will turn left, and a positive angle indicates that the wheels will turn right. Scenario 3 shows off the curve speed assist feature of the software. In this scenario, the user modifies the vehicle's initial speed, the coefficient of friction of the road, and the radius of the curve. An average coefficient of friction for a dry road is 0.70, and an average coefficient of friction for a wet road is 0.90. The software then calculates the angle of the wheels as well as a calculation for a safe speed for the vehicle to drive around the curve. In this scenario, the vehicle does not need to change its speed, as it is already within the safe speed. However, if the vehicle's initial speed is set to 80 miles per hour, we can see that the software slows the vehicle to the safe speed to drive around the curve. This has been the video demonstration for the functionality of the prototype for Cooperative Adaptive Cruise Control Team 2.